All right, today we're going to crack open one of the most powerful and, let's be honest, mysterious boxes in your neighborhood, the electrical substation. These things handle enough energy to power an entire city, yet most of us just drive right by without a second thought. So, let's pull back the curtain on these humming metal mazes.
You've definitely seen them, right? Tucked away behind a big chain-link fence, just kind of humming away. But what is actually going on inside all that complex-looking equipment? Well, that's exactly what we're here to figure out.
Yeah, I get it. It looks like a total chaotic mess of metal and wires. But in reality, that perceived mess is a highly organized, finely tuned system. It's an engineering marvel that keeps our lights on, our phones charged, and pretty much our entire world running. And we're gonna break it all down.
To really get what a substation does, we've got to zoom out and look at the bigger picture first, the electrical grid itself. Think of it as the giant circulatory system of our modern world, and the substation, well, that's its beating heart.
Okay, so the journey of our electricity is basically a three-step dance. First, it gets made, or generated, at a power plant. Then, a substation ramps up the voltage so it can be transmitted super efficiently over very long distances. And finally, another substation steps that voltage way down so it can be safely distributed to our homes and businesses.
So you see, the substation is that critical link between all these stages. It's kind of like the air traffic control for electricity, constantly managing the flow, making sure everything gets where it needs to go, safely and right on time.
Okay, so what does that management actually look like? Well, the first key job is something called switching. You can think of a substation as a massive, complex train yard, constantly routing power where it needs to go. For instance, if a power line needs to be taken offline for maintenance, the substation can simply reroute the electricity around it so you don't even notice. Now, this isn't like flipping a light switch in your living room, not even close. You can't just flip a giant switch off because the electricity is so powerful it will literally refuse to stop flowing. Instead, it will leap across the open gap, creating an explosive arc of plasma that's actually hotter than the surface of the sun. So substations use these incredibly sophisticated pieces of equipment, often insulated by special gas or oil, to safely break these circuits without creating a miniature lightning storm.
So, besides being a traffic cop, the substation is also the grid's heavyweight bodyguard. It's on watch 24/7 to protect all that incredibly expensive equipment and, of course, our power supply from getting damaged.
And believe me, the threats are coming from everywhere, all the time. We're talking about everything from a massive bolt of lightning down to, and I'm not kidding, a curious squirrel. Both of those things can cause what's called a fault, which is basically a huge, damaging surge of current. When that happens, the substation has to react in a fraction of a second to prevent a catastrophic failure.
Its primary tools for this job are fuses and circuit breakers. Fuses are the old-school one-and-done solution. A surge comes through, and they just melt to break the circuit. Simple, but effective. Circuit breakers, though, they're the smart, new-school solution. They're like giant, reusable switches that can be controlled from hundreds of miles away.
And then there's this really clever device called a recloser. It's a special breaker that knows a lot of faults are just temporary, like a tree branch brushing against the line in a windstorm. So instead of shutting the power off for good, it'll trip, wait just a second, and then try to reclose the circuit automatically. It's the reason your lights might flicker during a storm and then pop right back on.
And now we get to the big one, the absolute most important job of almost every substation: changing the voltage. This is called transformation, and honestly, it is the secret sauce that makes our entire modern grid possible.
Before we get into the how, let's talk about the why. The source material for this explainer put it perfectly. This simple but incredible fact lets us solve the grid's biggest puzzle. How do you send power hundreds of miles efficiently but still deliver it to your home safely?
So how in the world does it work? It's actually based on a beautifully elegant principle. Imagine you have two big coils of wire sitting next to each other. When alternating current flows through the first one, it creates a pulsing magnetic field. This field, in turn, creates a current in the second coil. And here's the magic trick. If that second coil has way fewer loops of wire than the first, the voltage it produces will be way lower. It's all about that ratio. So, here's the crucial takeaway. We step up the voltage to crazy high levels for long-distance travel because it loses a lot less energy that way. It's just more efficient. But that high voltage is way too dangerous for our neighborhoods, so the substation steps it down to a much safer level for local distribution right to your house.
Okay, so we've covered the three core jobs: switching, protection, and transformation. Let's bring it all together and talk about why this vital piece of infrastructure is so critical, not just for today, but for our future.
First off, safety is absolutely paramount when you're containing this much raw power. Those giant ceramic discs you see everywhere, those are insulators, and they keep all that high-voltage electricity from going where it shouldn't. There's a massive copper grid buried under the whole facility just to protect workers. And yes, those fences and warning signs, they are there for a very, very good reason.
And looking ahead, the substation's job is only getting more complex. As we move towards cleaner energy with more solar and wind, and as we all start plugging in millions of electric vehicles, our grid needs to get a whole lot smarter and more flexible. And the substation is right at the heart of that entire evolution.
So, the next time you drive past one of these facilities, I hope you don't just see a maze of wires. I hope you see the hardworking, unsung hero of our electrical world. And that leaves us with one final thought. As our world's demands change, these critical hubs will have to evolve, becoming smarter and more resilient to power our future. The story of the substation, well, it's far from over.